The silent giant of the streets. People call it a moving fortress. The name may seem strange, but we're talking about a vehicle that millions of people travel in every day. The bus isn't nicknamed that way for nothing. A welded steel frame, thick reinforced metal panels, and a total mass exceeding 12 tons. A bus has structural features almost identical to those of military vehicles. The only difference is that it's not in combat zones, but rather transporting people on their daily routes. Behind its robust shell lies a sophisticated manufacturing process, laser shaping giant steel sheets, assembling the frame, incorporating digital systems, and conducting performance tests in harsh conditions. In this documentary, we'll explore how raw steel blocks are transformed into vehicles capable of carrying hundreds of passengers on city streets. Designed to be robust, stable, and reliable, it deserves the title of Urban Warrior worldwide. More than 3 million buses operate daily, from school routes in the U.S. to urban areas in Europe and the narrow streets of Mexico's historic cities. More than simply a means of transportation, buses are a pillar of public transportation networks worldwide. With their uninterrupted schedules and constant demand, they have become one of the most widely produced vehicles on the planet. From production centers in China, Germany, and Brazil, they reach every continent. What makes buses even more captivating is the cultural identity they carry. In Guatemala, eye-catchingly decorated chicken buses shine with color and artistry, while in London, legendary red double-deckers stand as nostalgic symbols of the city. Each region tells its own story through the bodywork, color, and design of its buses, transforming them from ordinary vehicles into vibrant cultural icons of the communities they serve. In the modern bus world, the journey begins not with the engine, but with flat steel sheets. The raw material will form the frame of the entire vehicle. The steel sheets are retrieved from a high-bay automated storage system that can supply materials to the machines in under 30 seconds. The sheets are then fed into a high-powered, CNC-powered 3D laser cutting line. The laser pierces the metal, producing panels with sub-0.1 millimeter precision, even along curved lines. Beam cutting may sound fantastic, but it has become the industrial norm today. Guess how many of these panels are needed to assemble a single bus? After the cutting phase, the material moves to the forming station. Hydraulic presses apply hundreds of tons of force to shape elements such as sidewalls, roof sections, and structural ribs. Some components are folded using CNC bending systems, but specialized technicians are still required to directly operate and control them. This is a partnership between high-tech machinery and human expertise. This process creates a solid framework upon which the entire bus will be built. The bus's main frame is the backbone of the entire vehicle. A massive steel structure weighing more than 1.5 tons, it's designed to support the combined weight of the bus and its passengers. To build this foundation, dozens of rectangular steel beams are positioned on fixed templates with millimeter precision and aligned before being welded into a single unified body. Modern production facilities utilize MIG or MAG welding, prized for its speed and deep penetration. The majority of welding is performed by skilled craftsmen, supported by hydraulic clamps and robotic arms that maintain constant pressure. This reduces the margin of error and speeds up the process. Each weld is made at temperatures approaching 3,000 degrees Celsius. It melts the steel at the point of contact and fuses it tightly as it cools. The sparkling sparks are not only a visual spectacle, they signal the consistent continuity of the active weld flow. Once the main frame is complete, cranes, guided by a system of color codes and placement sensors, lift the roof and side panels into place. Each section fits precisely into its intended location. The frame's durability comes not only from the strength of its materials, but also from the seamless continuity of its welds. This is the foundation that enables a bus to operate safely and reliably for hundreds of thousands of kilometers. The newly welded bus frame cannot be directly assembled at this point. The entire structure is still bare metal. Weld marks are visible. The steel surface has not been protected enough to withstand harsh environmental conditions for years. The frame must first be treated and protected against rust. The process begins with a high-pressure wash, where hot water mixed with special degreasing agents removes welding dust, oil, and microscopic dirt. The frame is mounted on a carrier and moved step by step through a series of treatment baths by an automated crane system. Each tank is carefully maintained at a specific temperature, reflecting its specific purpose and chemistry. Acid bath to remove rust. Alkaline bath to neutralize pure water rinse. Finally, conversion coating bath. In this final stage, the steel surface reacts with a solution rich in zinc or manganese ions to form a thin crystalline layer. This layer, bonded directly to the base metal, provides the necessary adhesion for future protective coatings and serves as the first line of defense. When the frame emerges from the final bath, it passes through a control point where sensors measure the surface conductivity. If the measurements fall outside tolerance, the system automatically removes the frame from the line. Silent, invisible, yet essential, this protective layer ensures the bus resists corrosion from deep within its structure. If the skeleton is the body, the paint is the skin. The first element that allows someone to recognize or ignore a bus at a glance. This stage is much more than simply adding color. It's a delicate blend of engineering and aesthetics. Each factory showcases its own identity and standards. In some European facilities, automated spray robots, with arms as fluid as industrial artists, glide over every contour of the body, applying a first, smooth coat. This primer protects the surface and enhances adhesion for subsequent coats. Then come the coats of color, sometimes up to 3 coats, depending on the design or customer requirements. Especially for orders from the U.S., color tones are often requested with accuracy down to the Pantone code. Each painting step is carried out in enclosed booths with dust removal facilities, climate control, and strict humidity control are in place to prevent chips or streaks. While the machines handle the majority of the workload, employees focus on the difficult areas, curved edges, or frame joints, ensuring complete coverage under the lights. The paint reflects differently from every angle, creating a vibrant visual effect. Designed to protect the bus for decades as it plies the streets, it is also an attractive piece of protective armor. The central instrument panel, which defines the driver's area and directs the layout of the electrical system, is assembled first. This panel integrates the functional switches and wiring that connect to the speedometer, status display, steering wheel, pedals, and control software. The steering wheel is mounted on the steering column with a pre-calibrated torque connection. This early assembly allows technicians to accurately test the electrical connections before installing other components. The electrical system is then routed throughout the bus, following pre-designed schematics, from the driver's cab to the headlights, fuse box, air conditioning, and onboard cameras. Robots help connect the wires, secure the connectors, and install the clips, but each connection is still manually inspected. This phase is critical to ensuring stability once the bus is operational. From the lighting, horn, and warning systems to the Wi-Fi control, the software is loaded in test mode to verify the signals. Even a small phase misalignment can lead to cascading errors. Therefore, near-perfect precision is always a top priority. If the dashboard is the command center, the engine block and drivetrain are the powerful heart. This is where controlled data is translated into real motion. Before assembly, each engine block undergoes a complex process requiring the highest levels of mechanical precision. Cast aluminum blocks are machined using CNC equipment to precisely shape the engine cases down to the smallest groove. Pistons, camshafts, and valve trains are assembled by hand or in semi-automatic stations with tolerances nearly invisible to the human eye. Once the engine is ready, the integration of the drivetrain and chassis marks the moment when the frame becomes a real working machine. Automated robotic arms align and lift the hundreds-of-kilogram engine into precise position using laser and sensor guidance, ensuring that not a single component deviates from the specifications. The drive shaft, transmission, axles, and suspension are seamlessly connected, giving the vehicle its backbone. The structure guarantees power, balance, and driving feel. In many U.S. factories, this process is further enhanced by artificial intelligence systems that detect deviations in real time, increasing reliability and optimizing performance to near-perfect levels. The engine is ready to propel the vehicle forward, but at this point, the interior is an empty shell. The interior fit-out begins, imbuing the entire machine with soul and purpose. Rows of seats, armrests, curtains, ceiling lights, and decorative panels are transported into the cabin through the front and center doors, following a precise sequence of technical steps. Each seat is meticulously aligned. In some factories, they are positioned with sliding rails and floor-mounted guides to ensure proper spacing at the correct angle. Roller systems are used to push the entire row of seats in within seconds, reducing the need for manual handling inside the bus. The teams of technicians work in harmony, each responsible for a specific task. They work together like synchronized links in a chain. Seats, electrical wiring, and air ducts are bolted securely to the pre-installed floor. Smaller details, grab handles, storage compartments, reading lights, everything is inspected to ensure a secure fit and durability in such a limited space. Even a small misstep could mean rebuilding the entire interior with its internal systems. Technicians are now in the final stages, transforming the bare frame into a fully functional vehicle. Vacuum robots install the large curved windshield with fractions of a millimeter precision. The doors are positioned and manually secured by cranes, and the hinges are aligned before being locked at another station. The wheels are automatically installed with computer-controlled torque tools. Each bolt is tightened under strict monitoring. Some factories even use force sensors to prevent over-tightening. Every step reflects the synergy of human skill, combined with advanced machinery and industrial precision off-road testing. To verify real-world performance, the bus is taken to a multi-terrain test track within the factory grounds. Sloping ramps, raised bumps, slippery surfaces, and flooded alleys put the vehicle to the test, examining its stability, vibration resistance, traction control, and the waterproof integrity of its body. Each scenario simulates the challenging conditions the bus might face in real-world operation, from high-speed highways to rugged rural roads. This stage is not only the final confirmation of quality, but also the opportunity for engineers to review every technical detail once again. The bus's journey is just beginning. Each vehicle is wrapped in protective film and loaded into containers using automated lifting machines or hydraulic cranes. From there, they are transported to transshipment ports, dedicated to shipments to intercontinental destinations. The final destination could be a showroom in the U.S., a dealership in Europe, or a delivery center in Asia. All are mapped into a pre-programmed logistics network, the machine in motion, and with it, the global network activated in modern cities. Buses are vital, not only for transporting people, but also for reducing environmental impact. A single bus can replace dozens of cars, easing traffic congestion, reducing fuel consumption, and reducing CO2, nitrogen oxide, and particulate emissions that pollute urban air. Today's fleets increasingly utilize hybrid vehicles, natural gas, or all-electric propulsion systems. These systems produce little or no emissions. Each electric bus saves thousands of liters of diesel annually, preventing tons of greenhouse gases from entering the atmosphere. From bare steel frames to a fully equipped machine that sweeps the globe, the construction of the bus is not just a feat of engineering, but also a symbol of the seamless coordination between human ingenuity, advanced technology, and industrial vision. If this journey has touched your heart, leave a comment to share your thoughts. Hit the like button to support our production team, and don't forget to subscribe to the channel so you don't miss out on the next incredible technological journeys waiting to be explored.